Hi, I'm back. Miss Schulte in the house. Oh gosh. Okay, 2.2. 2.1, we sort of started talking about this exponential. We're going to stay in this exponential area here. And today we're going to look at exponential equations. So we looked at sort of exponential expressions before with exponents. And so now we're going to look at these equations and more specifically solving these equations. Okay. So as a review from 2.1, we saw the form of these exponential functions, which was b to the x power. B was the base, x was the exponent. So what we're going to have here are two sort of b to the x's that are equal to each other. And so there's two steps here to solving exponential equations. Okay. First, I want to express each side of the equation as a power of the same base. So what that means is I want my b's to be the same. Okay, and if they're not the same, I can't solve them yet. And so we need to change them into the same base. There's two things we need to remember when doing that. A base can only be changed using valid exponents, so I can only change bases using exponents. I can't like multiply or divide them. And usually a good thing to remember is to change bases into the smallest base possible. Don't try to make the numbers bigger. Try to make them smaller, okay? And again, the more that we do, the more that we work with exponents, the more that you'll start to recognize which ones go with each other, okay? And this is sort of the hard part. Once you have this, and once these bases are the same, set the exponents equal and then solve for the variable, and that part's pretty simple. So just getting through one is the more challenging. So again, we're trying to make the bases the same. Okay, so let's look at some examples. And I made some examples here and decided that I wanted to do 3 before 2, so I skipped, getting a little crazy and wild. All right, so what I have here are 2b to the x, b to the x, right? Two exponentials. And so we said our goal was to express each side of the equation as a power of the same base. So I want to have the same base. Well, you'll notice here that I do. 7 and 7, right? B's are the same. And so this is what I want. If they're not the same, that's when we have to change them. Okay? So since they're the same already, I can skip to number 2. Once the bases are the same, set the exponents equal and then solve for the variable. Okay? So because my bases are the same, I can set the exponents equal. So negative k equals 3k. Okay, and now I can solve. So this one looks a little tricky, but it's not really. I just want to get the k's together. So I'm going to add this k to the other side. These cancel, but they don't just disappear, they become a 0 equals 4k. And so now to solve for k, divide by 4, and k is equal to 0. There's my answer. Okay? So for number 3 here, you'll notice they're not the same. I have 16 and I have 64. So let's look back at those rules again. I want them to be the same. I can only change them using exponents. I can't multiply 16 times 4 to get 64. I can't do that. And usually I'm going to change all the bases into the smallest base possible. And so let's sort of check out our calculator. And again, these are going to come more familiar to you. I can only change these using exponents. Okay, so I notice that these numbers are probably related. They seem similar. But 16 times 2, that doesn't work. 16 times 4. All right, that one works. And so maybe I'm going to try to get 4s. Because 6, but what I wish I could take that back. Can I? Oh, good. I can't just do this, right? I can't just multiply. But it does help me see that the 16 and the 64 are related, and maybe by some 4s. I'll notice I can only change with exponents. So if I square 16, I already get 256, so that's so much higher than 64. I can't make them into the same. So my base, I'm not trying to make it into 16. Okay, a reminder that I said to try to make it smaller, so I want a 16, not 64. But maybe 4. Maybe 4 is going to work. Let's see. 4 squared is 16. Okay, that works. So what's 4? If 4 squared 16, let's try the next one up. 4 times 4 times 4. That's 4 cubed, right? And so that gets me 64. That's what we want. And so 16 is 4 squared. 64 is 4 cubed. And so I see that they're related. So my base that I'm changing them into is 4. Okay? Oh my gosh. Looks like a colon instead of a semicolon. Okay. And so really, these are just what I plug in. This 64 is easy because my exponent here is a 1, so I can just change this into 4 cubed. 64 is 4 cubed, so I can sort of substitute that in. This 16 becomes 4 squared. But this 2 minus 2x is already in the exponent, and so this 2 here multiplies by the exponent that was already there. 16 changes into 4 squared so that I have the same base. Now I have a base of 4 for both of these. This 2 multiplies by the one that's already there. And so now I have the same thing as this. The bases are the same, so I can make their exponents equal, and the bases sort of go away. So 2 times 2 minus 2x equals 3. Okay? Solve for x, distribute in the 2. 4 minus 4x equals 3. Subtract 4. Negative 4x equals negative 1. Divide by negative 4. And x equals 1/4. Okay? So, next. Oh man, I got this multiplying. Okay, so same thing, we want to figure out what our base is. Okay, and again, I'm going to try to use the smallest. I have a 5, and these both look like they potentially could be changed with exponents with a base of 5. So let's just check that out. I already know 5 times 5 is 25, that's 5 squared. So let's try 5 times 5 times 5. 5 cubed. Oh, look at that, it's 125, right? So here I have 5 cubed times 5 to the x. How about 625? Well, let's keep going here. Multiply this by one more 5. Then I'll have 5 to the 4th. Yep, there we go, 625. So 625 is 5 to the 4th. Okay, so here we made our base. Sometimes I like to just write out my base so I know what I'm trying to get. Base is 5. Okay, I can't really make them equal to each other yet though, because I need to combine this into one term. If you remember our rules of exponents, when I have two same bases multiplied, the exponents add. And so this is the same as 5 to the 3 plus x equals 5 to the 4th. Okay, so now our bases are the same, and we can do the same thing we did in the first two problems. The exponents are equal. 3 plus x equals 4. Subtract 3, x equals 1. Okay. One more. Look at this. So simple. Let's roll some dice first. Oh, yes. All right. Add that up. Enter it into your CPP. Yeah, that one's fine. Okay. Okay. Let's get rid of this now. I think we might be able to see this one. Here's a tricky part. What I notice is I have a fraction, and we sort of talked about this. But if I have a fraction here, I can change this. We know this is 3 to the 1st. I can make it into a non-fraction by moving it up into the numerator. When that happens, though, it doesn't stay positive. It becomes negative. Okay? So this is the same as 3 to the negative 1 to the negative 2n equals 9 to the n. Okay? So I can change this fraction into not a fraction. Well, it's still a fraction because technically it's over 1. But I can get this 3 into the numerator if I move it to the numerator and change this to a negative 1. And so, if you remember again, rules of exponents, when I have an exponent raised to an exponent, these multiply. And so here I get 3, negative 1 times negative 2n is to the 2n. All right, but I'm not going to write this side yet because, again, I need my goal of getting the bases the same. Okay, the base is the same. And so hopefully you notice that this 9 can be pretty easily changed into 3's, right? We know that 9 is 3 squared. And so here I have 3 squared, but I already have this n here, right? So this again is times n. And so now I have the same bases. Oh, hopefully you notice that these exponents are the same, aren't they? Base is the same and exponents the same. 2n equals 2n. Well, isn't that always true? No matter what I plug in here for n, these two values are going to be equal to each other. And so because of that, I can plug in anything in here, and my answer here is all real numbers. Okay? Again. Not again, but if that didn't work out, if there was no possible solution, then it's no solution. But here I can plug anything in, and so it's all real numbers. All right, I will see you in class. See ya.